So we'll show this again. Plus. Okay. So I want to know, first I want to know how many of these distances would fit into up to 1. How would I get that? I want to count how many of those would make up the distance from the x-axis to 1. So I'm really asking, what I'm asking is, how many of those would fit into 1, right? Isn't this counting how many of those distances would fit into 1? Take 1 and split it up into equal distances of 6 times 10 to the minus 64. And that's going to tell me how many of those fit in there. So how many is that? Someone?
1.6.
Okay? So I'm counting how many of these distances it would take to get from the x-axis up to 1. And it's just a few. It's just a couple, okay? And this is a number we can't even conceive. This is so incredibly huge, we can't even conceive how big this is, okay? All right, and so now how many feet? So how many feet now to get from the x-axis up to 1? Well, each one of these represents 5 feet, and I've got this many of them. So how many feet? Times 5. Each one of those is 5 feet. So if I take it times 5 feet, and what would that be? 8.33 times 10 to the 63rd feet. So from there, then I can get it in other different distance units. So I could find it in light years. I could find it in kilometers. I could find it in trips to the sun, trips to the moon. So I won't do all those. But probably what I've covered so far is where we got stuck, with just getting started. Okay? So now it's just a matter of converting this number of feet into those other distance units. Okay, questions on that example? Does that make more sense? Does that help? Okay, cool. So let's move on to chapter 3. And chapter 3 is about variables, constants, and parameters. What do you think when you see this? Everyone think to yourself, don't speak out loud. 2x plus 7 equals 0. What do you think when you see 2x plus 7 equals 0? I got my list. Going to start calling on people. Be ready. Come to lecture. Be ready. If you don't respond, it's like you're absent. Okay? Where's Lufin Chen? Lufin, way in the corner. That's okay. It's a great seat. All right. What do you see? What do you think when you see 2x plus 7 equals 0? What's that? Okay. So you think about the equation of a line, 2x plus 7. That's okay. How about, where's Ahmed Al-Bakri? Ahmed, tell me, what do you think when you see 2x plus 7 equals 0? What's that? A graph? Okay. How about Theodore Oberg? One more time. What do you think?
X is a variable.
You see x is a variable. Okay, so I just thought x was 3.5. Isn't x just 3.5? Is that right? Could it be 4?
No.
Could it be 10? The no's are drowning out. Are there any s's? Negative 3.5. I thought I'd fix this. I fixed it on one version of this, but not this version of it, Emily. Yes. Okay, negative 3.5. How about that? So now. No, actually, I want this to be net minus. I fixed this. I promise you I did. That's what I want. Okay, so is x 3.5? Could it be 4? Could it be 10? Could it be negative 0.5? Then you didn't do your reading.
Oh.
All right, suppose that same x, this is the same x now from that equation, is defined as the number of hours elapsed since your plane left the ground. And 2x minus 7 equals 0. Can x be 4?
No.
It can't be 4 hours since your plane left the ground?
Yeah. Oh, in that context.
Can it be 10 hours since your plane left the ground? Can it be negative half hour since your plane left the ground? What would that mean? That'd just be 30 minutes before your plane took off, right? 30 minutes before. So all these values for x are valid. 4, 10, negative a half. Okay? So what is 3.5? 3.5 is just the one value of x that makes that statement true. So those are valid values of x. They just don't make this statement true. They make it false. So this is the way we want to think about variables. Variables vary. They stand for quantities that vary. So what values can x take on here? The number of hours elapsed since your plane left the ground. What values can that take on? Where's Austin Baker? Austin, what values can x take on if it's the number of hours since your plane left the ground? Any real number. 0, 0.1, 0.2, 0.25, 0.5, 1, 2, 2.1, 2.9, 3.2. All those are valid values of x as a number of, and so we want to think, in this course, we want to think about variables as varying through their what domain? Through all the possible values that it can take on. So x equals 3.5 just simply highlights a particular moment on the flight. Okay? All right, so here we go. A variable, two things about a variable. It's a letter or a notation. That's number one. And it represents the value of a changing quantity. Variables vary. Variables vary in the value they are representing. But first or foremost, what is a variable? A letter. What is a variable? Everyone.
Letter.
Everyone.
Letter.
What is a variable?
A letter.
How about this phrase right here? See this phrase in quotes? Just the phrase in quotes. Is that a variable?
Yeah.
The phrase in quotes. Is it a variable? What is a variable?
Letter.
Is the phrase in quotes a letter? Okay, if I said x equals the number of hours elapsed, that's x is the variable. In quotes is the quantity, the varying quantity that the variable is taking on. What is a variable?
Letter.
A letter. Or a notation, okay? It could be a string of characters, okay? So a constant is a non-changing value. Constant, it stays the same. So we would never use a variable to define a constant. Okay? So constant is non-changing, but we can use a letter to represent a non-changing value, and then we call that a parameter. A parameter is a letter that represents the value of a constant, something that's not changing. What is a parameter?
Letter.
Louder.
Letter.
A parameter is a letter. So I'm making a point so you guys can succeed on the question on the test. Because in the past 2 semesters, students have forgotten that a variable and a parameter, they are letters. Letters. So what's the difference? A variable is a letter that represents a changing quantity, and a parameter is a letter that represents the value of something that's constant in the situation. I hope you hear it in your sleep tonight. All the students in this room saying, a ladder, a ladder, a ladder. I can't sleep. So if in the, what you got to have the context. So it would matter the context. So if B is in the context, if B always holds constant, then it's parameter. But it's possible you got AX plus B and B is changing in the context. So it's just all about the context of the situation. Okay, so the domain of a a parameter doesn't have a domain because it just stays the same. But the domain of a variable is the set of all possible values that variable can take on. It's the set of all possible values that the variable can take on as it changes, right? So it's a changing quantity, changing value. Domain is all possible values it could take on. Where's Miranda? Baraker. Miranda, what's a variable? What kind of letter representing what? Changing quantity. It's a letter that stands for some quantity that's changing. Okay? It's not wrong to say that all of calculus is about how changing quantities change together. That's what the study of calculus is. It's modeling how two changing quantities change together. And remember, then we have the two subcategories, right? You know how fast a quantity is changing. You want to know how much of it you have. You know how fast a quantity is changing. You want to know how much of it you have. Or the other side of the coin is you know how much of the quantity you have. You want to know how fast it's changing. Okay? But just overall, calculus is about changing quantities, specifically how two quantities change together. All right, so let's look at some practice of this. Okay, so this animation right here doesn't have to make sense to you now, but it's good practice for what we're talking about here, variables, parameters, constants, and domain, okay? So in about 3 or 4 weeks, we're going to be understanding what's going on here, okay? So we will return to this after we lay down a lot of groundwork. But in the meantime, we can just use this as a foreshadowing, but then also as an exercise to figure out what are the variables and what are the parameters, and then what are the values of the parameters, right? It's constant, so it's a parameter, it's constant. And then if it's a variable, what's the domain of the variable? What values can it take on? So we've got a, dx, left x, delta x, and x. All right, see that list up there? 5 different notations. Each one of those is either a variable, and we want to then identify it as a variable and figure out what its domain is, or it's a parameter, so we want to identify it as a parameter and ask what constant value does it have. Okay? So you can work together, take a couple minutes, identifying each one of those 5 notations as either a variable or parameter. If it's a variable, what's its domain? If it's a parameter, what's its constant value? Go. Work together. Here we go. See how we did? Where is Madeline already gone? Where's Logan? Logan. Lowry? Lahid, sorry, Lahid. How about A? Tell me about A. Variable or parameter? He's going with parameter. Agree? Yep, it's parameter. And then what is its value? If it's a parameter, it's a constant value. So what is its value? 0.5. What do we think? Awesome. Okay. Next, dx. Where is? I can't read that. Is it Katja? Katja? Did I say it right? Katya. How about dx? Variable or parameter? Parameter. So dx is a constant value. What do we think? So this is the blue. So it's showing the blue quantity here. Yeah, it's changing, right? It's changing. And so what is its domain? Can you see from what to what does it vary between? So it always starts at left x. It always starts at the red. And then it's this increasing distance to right there, and then it starts over. So what's the domain of that? No, so it starts here, right? It's a distance. It's always starting here, and then increasing to there. Where is Mara Chavez? You see what the domain of dx is? So it starts, and then it increases, and then it starts over. So what is it starting from? What's its minimum value? It's a distance. 0, right? 0. Do you see? The length of the blue arrow is showing you the current value of dx. So it starts at 0. And then what's the maximum value of dx? 1.5. And then once it hits 1.5, it starts over in a different place. Does everyone see that? So the values of dx are kind of represented by the length of those blue arrows. Always starts at 0, and when it hits 1.5, it starts over. So the domain for the value of dx is 0 to 1.5. How about left x? Where is Adrian Fitcher? Adrian here? Yeah. Variable or parameter, left x? Is that change? Is that value changing or staying the same the whole time? I just saw it change. You see? It's changing. It's changing, right? It's changing. It stays the same for certain values of x, but then it changes. This is a variable, right? It's varying. So what is the domain of this one? All possible values could take on. Well, they're discrete values, right? So it's not continuously increasing, but it is changing in value. So what does it start at? 2 in this animation? Starts at 0.5? So yeah, so in this particular animation, it's starting at 2, and then what's its next value after 2? 3.5, and then what's its next value? Then 5, so it's just going to keep increasing by each. I'm not sure what the last one is in the animation, but you get the picture. So it's a changing value, but it's discrete values. 2, 3.5, 5, 6.5, 8. But it is a variable because it's taking on different, it's changing, right? The value is changing. Okay, delta x. Where's Robert B? Blankenbaker. Yeah. Do you think delta x is, it's represented by the length of that purple bar. Is that parameter or variable?
Parameter.
That's a parameter, and what's its value? No, if it's a parameter, it only has one value. It's a constant, 1.5. The value of delta x is 1.5. It's the length of these intervals. It's the width of these intervals. So it's always this fixed amount from the start to the end of the current interval. So they're 2 to 3.5. So its distance is 1.5. Everyone see that? It's a parameter?
Yeah.
What about x? Everybody? That one's easy. Variable. Okay? The domain is from? So it actually starts somewhere over here, but really it actually starts at A. So we can use, look, I'm using a parameter to help define the domain of a variable. Look, so A is the starting value of x, and so it's the lowest value that x can take on. So it's A, and then, I don't know where the animation stops, but we'll just say x takes on A to 17. Great. So x takes on all the values starting at A up into 17, right? It's just continually increasing through all real numbers starting at A, ending at 17. Questions on this exercise? Like, there's one you think it should be parameter. Yeah, please. Okay, so look at the value of left x. Right now, what's the value of left x? 3.5. Now it's 5. Yeah, but delta x is a length of an interval. It's a length, or it's a distance across an interval. And even though it's moving to different intervals, the intervals all have the same length. So it's always 1.5. Now it's 1.5. Now it's 1.5. You see? So it's the distance across that purple bar, which is always 1.5, no matter where you put it. But left x continually changes in value. It's always the starting value of that interval, and so that's changing. Now it's 3.5, now it's 5. So they're like apples and oranges, right? Delta x is a length from one x to another. Left x is a particular value of x. Okay? Good question. Other questions? Yes, please. Oh, okay, so that's the line is showing you how the value is measured, right? So x, if you want to think of the x as that distance, that length of that black arrow. Does that make sense? So if x is starting at A, then its value is the length of that arrow right there, from there to there. Does that make sense? So the arrow isn't showing you where the first possible value of x, it's showing you how we measure x from this y-axis. Is that better? Other questions? Okay, so let's just take a couple minutes now to practice. I'm going to show you another situation here, a real-world situation, and we're going to... So here, Clara the calculus cow has been tied to a silo with a radius of 2 by a rope attached at the westernmost point, there at -2. So that blue is the rope, and it's wrapped around the silo. And the rope is just long enough for her to reach the easternmost point, where she is now. So if she walks out keeping that rope tight, this is what her path will look like. Okay, she's going to walk out, and she's going to keep that rope as tight as she can. And this is what it'll look like as that rope unravels off the silo. And that pink curve will be her path as she does that. All right, and there's a fence down here. There's a fence, so she can't go past the fence. And so she'll come back. Okay? All right, so what I want you to do is I want you to create, say, 3 or 4 parameters in this situation. And a parameter is? A letter that represents a constant. So you're going to come up with 3 or 4 of those. That means you're going to dream up a letter and then tell me what that letter represents as a constant value in this situation. And then you're going to write 3 or 4 variables in this situation. And a variable is? A letter. Okay, but that letter is going to stand for some quantity that's changing in this situation. And you're going to dream up 3 or 4 letters and assign them to changing quantities in this situation. You can do it with the person next to you, or you can do it by yourself. We want to practice identifying what's changing and what's constant in the situation, and then you're gonna create your own letters, variables for that. Okay, we're gonna see what you guys came up with. Okay, one thing about my list: if you get called, it doesn't mean you won't get called after I've called everyone else. The way I have it randomized is you can get called twice in the same day, and this is going to happen here. Madeline, you're next. Madeline you go twice today, so you get to choose. What was a parameter or variable you came up with, Madeline? That was you, right? Where's Madeline Ramos? Sorry, I know I did call on you though. Okay. The length of the rope, and so is that a parameter? The length of the rope.
Yes.
A parameter is a letter. So tell me again. What is it? R is the length of the rope. Have I made my point? I'm not mad. I just want you to learn. Okay. R is the length of the rope. And what is the value of the length of the rope? Exactly. Can we describe it exactly? What is it? 6? Where's the 6 coming into it? Yeah. That's not the exact length of the rope. Nope. Okay, circumference of a circle is 2 pi r, and we want half of that. So the length of the rope is 2 pi. 2 pi meters. Okay, who's next? Randon, Sharma. Tell me, a variable or parameter? Say it again? T equals the change in what? What do you mean by the change? So what quantity are you thinking about? The length of it?
Yeah.
Is that variable or parameter? Variable. So t is the length of the pink curve. Okay? So can we make that more about the situation, right? So can we relate that to Clara? What would that be in terms of Clara? T is it's not distance from the silo, but isn't it? Is there distance walked? From the east side of the silo, east point of the silo. Is it a variable?
Yeah.
Okay. And it has a domain. So, and that domain would be from what? 0 to the length of that pink curve would be all the possible values of t. So the length of the boundary she's walking there would be the maximum value, and then 0 would be the minimum value. Okay, let's do one more, and we'll do top hat. Where is Adam McGurr? Adam. Oh, Aiden, sorry. My eyes are going. You choose. Parameter or variable? What do you want?
I'll do it for parameter.
Okay, and what is your parameter?
B is equal to the parameter for beginning distance from the tether.
Say it again? I didn't hear you.
B is equal to the parameter for beginning distance from the tether.
Beginning distance from the tether. So what distance is that? From where to where? I'm not.
I guess I was kind of just imagining since the tether's on the west side.
Okay.
Distance from
Oh, so from where the cow starts to this point? Okay. And how else could we define that? Yeah, the diameter, right? So d is the diameter of the silo. That's non-changing, so that is a constant. So you could say d is the diameter of the silo, and we know what that value is. It is? That's 4. 4 meters. Okay. Questions? So we could come up with 10 of each here in this situation, right? There's lots of things that vary here. The amount of area that Clara has grazed in. Okay? How much area Clara has grazed is another good variable. Let's call that A, right? A. Area that Clara has grazed in. And if M is the total possible area Clara could graze in, that's a parameter, right? Then what's the domain of capital A? What's the domain of capital A? 0 to M, right? She could have grazed none all the way up to the whole area that she could possibly graze in. So it takes capital A could take on all these values from 0 to capital M, where capital M is the parameter, the total possible area she could graze in. Does that make sense? Okay, top hat, let's go.